Okay, the name of my project was Determining Vulnerability of Ceratocystis fimbriata to a zoxystrobin fungicide. I thought that the fungicide would stop all growth of the fungus at my highest concentration of fungicide, which was 100 ppm. I found that my hypothesis was partially supported because although the growth of my fungi wasn't completely stopped at the highest concentration, the radial growth of the fungal colonies did decrease.
And is that what you expected, or what happened during the process?
I expected the fungus to be the growth of the fungus to be completely stopped at the highest concentration because the fungus hasn't had any prior contact to the fungicide. So I thought it would be really vulnerable to being killed by the fungicide, but apparently that wasn't true.
So what is the application for this in the real world?
It could be used to control the spread of rapid ohia death, which has been devastating native Hawaiian forests since 2012.
Now that rapid ohia death, only ohia trees, or are there other plants or trees involved?
The fungus also attacks trees like the American sycamore tree, sweet potato, and cacao trees, but I was using this specifically to fix rapid ohia death.
Okay, well that's really cool. And who would you like to thank?
I would like to thank Miss Anglin for all of her help, and also Tina Michael, my botany professor at WCC, and also Chris Kataoka, my research mentor at UH.
My project is the design and construction of a compact collapsible skateboard. I came up with this idea by not wanting to carry a skateboarder on my side all day because it's heavy, and I don't know, it'd be nice to put in a backpack. So that's what I made, skateboard that I can put in a backpack.
Okay, so it's a practical application.
Yes. I'm trying to make it practical.
What kind of expectations did you have for this?
I wanted it to be small. I also wanted it to be compact but strong so that it's safe. That was kind of a main concern. And that was probably the hardest thing to do, is make it so that I could stand on it, but also make it fold. So.
And what were some of your biggest challenges, and how did you overcome those challenges?
I think by far the biggest challenge was trying to find a way to make it lock into place when it's unfolded so I can safely ride it. And I went through a couple of different testing methods and different ways to lock the board up, but I came up with a pretty safe solution.
Which is?
Which is a metal bar that runs through the middle of the board. It has these metal bars on either side that slide into place, and then it just locks. So then it's a sturdy-ish skateboard that I can ride to school.
So it flexes enough so you can do some good moves?
Yeah, all the time.
But doesn't the deck need to be pretty rigid so that you can, maneuver and do what you need to do?
It does, and it's a little scary when you're riding and you can feel it moving underneath your feet, but it actually makes it a lot of fun.
And then what about the rest of your hardware? Is it standard wheels and trucks and stuff?
Yeah, pretty standard, pretty much all stuff lying around my house. The only things I bought was the metal bar and the hinges.
Okay. And what is the potential you think? Would you market this? Can you make some make some big bucks marketing this product?
It would be pretty hard to. I mean, maybe with some more testing and making it lighter and more strong. Definitely more strong. It's a little heavy at the moment, but this definitely could be marketed and sold.
You better put a trademark or copyright on all your ideas.
Make my own little company. Yeah.
Protect your intellectual property.
Yeah.
Any thoughts for doing maybe a longer board?
That'd be cool. A long board, making it foldable. I mean, even when it's folded up, it'd still be pretty big, but I probably can make it work. Yeah. I would like to thank Miss Anglin. She helped me out a lot through this project. Yeah. She helped me come up with this idea and kind of guided me through it. So yeah, thank you, Miss Anglin.
My title is Exosomes, a novel Zika virus vaccine candidate. And basically what we're dealing with is exosomes, which are a class of extracellular vesicle. And there are two key proteins on the exosome surface, CD9 and CD63. And we hypothesized that fusing the genes for those two exosome proteins with two Zika virus genes envelope an NS1 to create a gene fusion would allow the exosomes to carry the Zika antigen out of the cell once they're released.
what is the Zika virus, or what is the problem that you're trying to solve? And what is the disease do to humans?
Zika virus is a flavivirus that is transmitted through the bite of an infected Aedes mosquito. It's commonly found throughout the subtropical regions of the world, mainly like Brazil and other areas of South America. In normal adults, it usually causes flu-like symptoms, but it can be transmitted vertically from mother to fetus. And usually, or sometimes it causes things like microcephaly, which is the abnormal small head that you see in infants, or in adults it can lead to Guillain-Barré syndrome, which causes paralysis. I'd like to thank my two mentors, Pakieli Kaufusi and his graduate student, Alana Sang, and my teacher, Miss Sarah Anglin.
So my project's called Wrestling Off Bacteria, and it's basically the study of Staphylococcus aureus bacteria and methicillin-resistant Staphylococcus aureus bacteria in the high school athletic facilities at my school. So I basically tested 2 athletic facilities at my school for these 2 types of bacteria.
And what was your hypothesis?
My hypothesis was that I would be able to find either one of these bacteria in one of the facilities that I tested.
And what are some of your challenges with this project?
A challenge that I faced was definitely keeping all my plates organized, because I did use 5 types of agar plates, so that equaled to 90 plates total. So it was really hard to keep them organized, but I made sure to label them and everything.
And so after you finished your project, what did you conclude?
I concluded that I think based on the colony morphology of the colonies that did grow, staph was able to be found, but more research was definitely needed to conclude that statement.
And what is the real world application like? You're going to create some kind of product, I can clean my bathroom at home, or what do you have in mind?
I would definitely say just like using that information and making sure to push my school to take better care of the facilities, and maybe educating the students more about like the different types of bacteria and possible infections and stuff like that.
So worst case scenario, somebody could get ill from someplace that's not sanitized?
Mm-hmm, yeah. Yeah.
Okay. And who would you like to thank? Teachers, mentors, family?
I would definitely like to thank Miss Anglin, which is my science teacher, because she really helped me put together my board and really helped me interpret the data, as well as my professor, Professor Michaels, because she really helped me understand like bacteria and stuff like that.
Tell us about your project that you and your partner put together.
So our project is called Alterations in Propeller Design and Their Effects on Thrust Output. And basically what we did is we designed a bunch of prototype propellers and altered the different pitches of the propellers, which is the distance it travels in one rotation. So we used SolidWorks to model different blade angles, and then we created a testing device and measured the thrust output in newtons that each propeller exerted when tested under a constant power supply under constant conditions. So we made 6 prototypes, and we designed our propellers to be multi-directional, which means they can travel in both the forward direction and the backwards direction, while most propellers are only single directional. So the purpose of our prototypes was to be comparable to the single directional propellers, while also being able to go in multiple directions.
And what kind of challenges did you have with this project?
So some challenges we had was in the modeling process, since me and my partner both did not know how to 3D model propellers. So we went to a mentor who is a student at UH who taught us how to model propellers, and he gave us the 3D printing software SolidWorks and taught us how to make the different angles. So prototype B printed really thin, and because of that, it actually had a higher thrust output than the other propellers. So from this, we concluded that we could use the thinner materials that have less resistance underwater, and then in the future we could test different materials instead of just the different pitches to see how that could be used in a practical way.
Can you tell us what is a real world application? Like, will these propellers be used on airplanes or ships, or what is this for?
So the most important part of a ROV, or remotely operated vehicle, is the propeller. And our propellers are designed to be used for underwater ROVs. underwater ROVs are important to collect data underwater in places where humans can't go. And a multi-directional propeller is important because if it's only single directional, it'll only be able to go forward. And ROVs need the flexibility of going in multiple directions so they don't get stuck and so they can collect the best data. I would like to thank our robotics mentor, Chris Cambos, for helping us learn how to 3D model and test the propellers. And I would like to thank my partner, Miles Jenkins, for basically doing half of our project with me. I would also like to thank our teacher, Miss Anglin, for helping us learn how to put our display together and how to answer all the questions that the judges would be asking us.